103, Exponent Rules Part 2. We're going to start off by looking at a couple of examples where we simplify and then come up with some ideas about negative exponents. So for our first example, we have x to the fifth divided by x squared. We're getting pretty good at problems like this. We know to visualize x to the fifth power would be x times x times x times x times x. We would have 5 factors of x in the numerator. In our denominator, x squared would be x times x. So we'd have 2 factors. And we know that anytime we have x divided by x, that's a 1. So really, we're taking away 2 of those factors. And so we are left with x times x times x, which is x cubed. We know we can get that also by looking at our exponents here and subtracting them. So that's kind of what we learned. So we learned that this visualizing technique can help us remember what's going on, but then the shorthand rule tells us subtract to get the exponent. So it's kind of weird on the second one because when we go to subtract, we'd have x to the 3 minus 7 power, which is x to the negative fourth. So it makes us wonder, like, what is going on? What is up with negative exponents? So we're going to go back to that visualizing idea again. X cubed means I would have x times x times x, 3 factors of x. In my denominator, I would have 7 factors. So what's interesting about this one is we can still cross out that x over x factor because x divided by x is 1. But this time, I don't have anything left in my numerator. So that's going to be a 1. All 4 factors of my x that are left over are in my denominator. So I have 1 over x to the fourth. So this is where our definition for negative exponents comes from, because it turns out that this x to the negative fourth power that we came up with and our 1 over x to the fourth, those are equivalent. The negative exponent property says that if I have a negative exponent, then I basically just take a reciprocal. So a to the negative n power is 1 over a to the nth. If I have a positive a to the nth power, I can make that 1 over a to the negative nth. So basically, if we have something that's a negative exponent in my denominator, I move it up to a numerator. If it's in a numerator, I move it to my denominator. So whenever we have a negative exponent, we can just move that, flip it between the numerator and denominator, and take the reciprocal. So an example would be if I have 3 to the negative 2 power, that's going to be 1 over 3 squared. It was negative, so I had to move it to a denominator, take the reciprocal, which is going to be 1/9. An example for our second rule is that if I have 1 over 4 to the negative 2 power, because it's in denominator, but it's a negative exponent, I need to move it up to the numerator. And that will change that sign on my exponent to a positive. So 1 divided by 4 to the negative 2 power is just 4 squared, which is a positive 16. So negative exponents do not make negative numbers. They just make reciprocals. We have a handful of examples here, 5 examples on negative numbers. So we're just going to kind of work with these right now. Move my multiplication symbol back over. So on my first one, I have negative 8 being raised to a negative 2 power. Since a negative exponent, I want to take the reciprocal. So now I have 1 over negative 8 squared. So again, it changes the sign on my exponent. The 8 is still negative. That does not change. Negative 8 times negative 8 is a positive 64. So my answer is 1/64. And problem 2, my negative exponent is in the denominator. So that means I need to move it up to the numerator in order to change the sign on the exponent. So now I just have 2 to the third power. And 2 times 2 times 2 is 8. On 3, my number is in the denominator with a negative exponent, so I'm going to move this up to the numerator. And again, it does not change the sign on the 4, only the exponent. So now I have negative 4 squared, so it's a positive 2 exponent. And without the parentheses, it means I square the 4 first. So I do the exponent part first, and then I make it negative. So this is going to be a negative 16. So the parentheses in number 1 versus no parentheses in 3 give us a very different answer. And last on 4, I have an exponent that's a -3. So I need to take the reciprocal and make it 1 over 5 to the third, or 1 over 125, 1/125th. So 5, I have the same base. I have -3 is the same base on both of these. And I know that when I have the same base, I am allowed to add my exponents. So I am going to take 5 and -5, and I'm going to add those together. Well, that would make a 0 power, and anything raised to 0 power is 1. That gives us a nice little review of properties we did earlier. Next, we're going to look at power of a power property. So again, I always like to kind of give you a sneak peek first and do a couple examples that make you think about how that property might work. And then we'll go back and write it in terms of variables with like A's and M's and N's. So first we're going to look at 1. So I have this whole thing, x cubed, in parentheses, it's being squared. So something squared means multiply by itself. So that means I have x cubed times x cubed. And I know x cubed is x times x times x. And then the other x cubed is x times x times x. So x cubed here was 3 factors, and then I multiplied by 3 more factors. So altogether, I would have 6 factors of x. Let's look at the second one. Here, 5 to the 4th is being cubed. That means 5 to the 4th times 5 to the 4th times 5 to the 4th. And even once you learn the properties and the rules here, there's no shame in writing this out so that it makes more sense to you. We're always trying to really conceptualize this and understand math and not just memorize rules. So 5 to the 4th would be 4 factors of 5 times another 4 factors times another 4 factors. So that means I would have 4 factors for the first one and the second one and the third one. I have 3 groups of 4 factors. So that means I will have 5 to the 12th power. So now we need to think about a rule that will always work. So we want to look at the 3 and 4 here in the second example. We want to look at the 3 and 2 in the first one, and we want to figure out how do we get to that exponent just doing a basic operation. So it turns out when we have a power raised to another power that we can multiply. So the power of a power property is if I have a to the m power and then I raise it to the nth power, I need to multiply my exponents. Next, we have the power of a product property. So again, we're going to look at a couple examples and see if we can figure that out. So now I have xy together being multiplied, being raised to third power. So third power means I have 3 factors of whatever's in the parentheses. So I have xy times xy times xy. So really, when I have xy, it really means x times y, doesn't it? Like I could write in all those little multiplication signs if I wanted to. I'm going to make them all blue. So we have an xy from the first one and the second one and the third one. We multiplied that together 3 times, but there's no law that says that this x and y have to just be by themselves together. Like this x and y are not married. I can take this x and this one and this one. I can put them all together and write them shorthand as x to the third power because I have an x times an x times an x. So I can reorder the way I multiply something. Similarly, we have y times y times y, which is going to be y to the third. So let's go ahead and look at example 2, and then we'll come up with our property. So 18 times 3 is being raised to the 5th power. That means I'd have 5 groups of 18 times 3. I'd have 5 factors of that. And just like the last one, I want to put like things together and multiply them together so I can shorthand it. I have 5 factors of 18, so 18 to the 5th times. I have 5 factors of 3, so now I have 3 to the 5th. So 18 to the 5th times 3 to the 5th. So it's almost like we're distributing. That's how a lot of people remember this. It's like I'm taking that exponent and I'm distributing it over multiplication. It has to be multiplication. It will not work if it's addition. Same thing on this one. It's like I took this third power and I distributed that. So we can distribute exponents over multiplication. So this is going to be, for our property, if I have a times b to the nth power, I have a to the nth power and b to the nth power. We're going to look at one more property and then do some examples to kind of put it all together. So next we have the power of a quotient property. So quotient means something that's being divided. So our property here is showing a divided by b raised to the nth power. And we're going to first work through some examples again and see how that goes. So if I have x divided by y, but then raised to the third power, that means I would have 3 factors of x divided by y. So I could write it as x over y times x over y times x over y. Well, we know to multiply fractions, we multiply all the numerators, we multiply all the denominators. So x times x times x, I can shorthand and write as x to the third. Y times y times y, I can write as y to the third. So it turned out that I distributed that exponent to the numerator and denominator. Let's see if that works in the next one. I have negative 7 over x being squared, which means I have a negative 7 over x times itself, negative 7 over x. So there's 2 factors. Negative times negative is positive 49, and x times x is x squared. So again, it's like I took that 7 and I squared it, or a negative 7 and I squared it, and I took the x and I squared it. So we're going to write this property. If that fraction is being raised to the nth power, we're going to write that as a to the nth divided by b to the nth. So the numerator and the denominator both get that exponent. For our last example on this one, we're going to kind of put some different things together, and we're going to use our properties this time. So I know my 4 and my x squared are being multiplied together. So that means I can take the third power and bring that to both the 4 and the x squared. So I will have 4 to the third power. And then if I have x squared being cubed, that's power to a power. So I'll be multiplying those and getting x to the 6th. So it helps me to think of it as 3 groups of x squared, or 3 factors of x squared. And that helps me remember that I'm multiplying. I can distribute exponents over division also. So I'm also going to be raising 5 to the third power and y to the third power as well. So now we're just going to go through and kind of clean this up. 4 to the third power is 64, x to the 6th, divided by 5 cubed is 125, y to the third. So now we're going to look at 5 examples that will kind of help prep you for the quiz problems, the 1.03 quiz. There's a lot of different ways we could work out example 1. Whenever you're stuck, I recommend writing it out. You can always use scratch paper and then go back and look for your answer. It's just so much easier than trying to do math in your head. So 11 to the 4th, I know would be 4 11s, 4 factors of 11, all multiplied out. 8th power for my denominator, that means I would have 8 factors of 11. And then I know that 11 divided by 11 is 1, so I can take away, and I'm always trying to use the words take away because I think it helps you remember our rule. I can take away those 4 factors of 11. So I am left with 4 factors of 11. So that would be 11 to the 4th power. And then in my numerator, I would just put a 1 because 11 divided by 11 is a 1. It's almost kind of like a placeholder. I have to have something there. I just can't write 0. 1 and 0 are not equivalent. Since 11 over 11 is 1, we'd write a 1 there. In example 2, we have a negative exponent right away. So my advice is always that when I have a negative exponent, to make them positive, because the positive exponents are easier to work with. So by taking a negative exponent and changing it, we change it to something that we already know how to do. So if it is a negative exponent in the numerator, I need to put it in the denominator. So in my denominator now, I would have 3 to the 5th times 3 squared. Because I took the reciprocal there, I would just be left with a 1 here. And then in my denominator, I can think about how there's 5 factors of 3 times 2 more factors of 3. And so all together, I would have 7 of them. so 3 to the 7th power. And I could write that out if I needed to. But I'm always trying to use that language that shows I really understand math, and then I can kind of visualize and conceptualize what's going on. For example 3, I have 7 to the 5th power, and I've got to raise that to the 3rd. Same thing with my denominator. I have 2 to the 4th power, and I have to raise it to the 3rd. So we need to remember that we're raising a power to a power. We're going to multiply our exponents. If you wanted to see that written out, I could write 7 to the 5th over 2 to the 4th times another factor of 7 to the 5th over 2 to the 4th times one more factor of 7 to the 5th over 2 to the 4th. Third power means 3 of those factors. And so I have 5 7s being multiplied, and then 5 more, and then 5 more. So altogether, I would have 7 to the 15th. In my denominator, 2 to the 4th times 2 to the 4th times 2 to the 4th, I would altogether be multiplying 12 factors of 2. So remember, we can get that by multiplying our exponents. For example 4 is asking us, what operation do you use for the exponents in order to simplify the expression? So operation would mean adding, subtracting, multiplying, dividing. So we want to think about, for each problem, what are we actually doing? So let's start with the first one. 4 to the 7th means I would have 7 factors of 4 written out, and then I'm multiplying by 6 more factors. I would have to be adding up how many there are altogether. So this one's going to be add, and my answer would be 4 to the 13th. We'll go ahead and do answers too. It's good practice. On the next one, I have a power. 5 is being squared, and then I have it raised to another power. So whenever we have power to a power, we are multiplying them. So this would be 5 to the negative 6th power, which we know is 1 divided by 5 to the 6th. So whenever we have a negative exponent, we do a reciprocal. I have no idea what 5 to the 6th power is. I'm okay with leaving it that way. Same thing with the 4 to the 13th. When they're really high powers, you'll notice when you're choosing those multiple choice questions, they're not going to actually work it out and give you a number. On the next one, I am taking 3 to the 10th power and dividing by 3 to the 3rd power. So remember how we write them all out, and then we're crossing out, we're taking away those 3 factors of 3 that they have in common. So we are subtracting those exponents. And 10 minus 3 is 7, so we would be left with 3 to the 7th. On the last one, I have fractions, which is kind of meant to confuse you, but the idea is really, what are we doing with the exponents? So if I have 1/5 squared times a 1/5 to the 3rd power, altogether, how many factors of 1/5 would I have? So I'm adding them together. And my answer would be 1/5 to the 5th power. Last example, simplify and write without negative exponents. So there's a lot of different ways to go about doing this problem. Some people like to get rid of that negative exponent right away, but it's kind of weird because it's on the outside. I always find it's easier in this case. I recognize right away that I have a power to a power, so I can multiply these two and get 7 to the negative 6th. Because it's a negative exponent, I need to make it a fraction. And then I'm going to stop there. I'm not going to worry about what 7 to the 6th power actually is. Please reach out to your teacher if you have questions about any of this, if you need more help, if you need examples. Thanks, and have a great day.